Today we are going to talk about how to solve simple linear equations in one variable here. So the wording might sound a little confusing, so let's go over what I mean by simple and what I mean by linear and one variable and so on. So simple linear equations. So these equations that we are going to talk about are linear equations. Linear means that there is only one power of x present here. It's only equations in an unknown, that is x or y or z, but there is no higher power. There is no x square or x cube, or there is no higher power of this variable involved in any of these equations. So that's what I mean by linear equations. The equation is linear in x because it is the first and only power of x that is present in the equation. That is the first power. And for completeness, what is a variable? Variable is something typically denoted by x or any other letter whose value is unknown, and the objective is to find the value of that variable given other information. So let's take a few examples. Let's make them progressively more complex to see how we can solve these simple equations that can come up in various contexts. So suppose you want to calculate the distance a train travels in a 1 hour, and you are given the speed, or you are given distance between 2 points and you are given the speed. Then how long does it take for the train to travel between 2 points A and B? Or many other examples or many other instances where one quantity is unknown and you need to figure out what that one quantity is, and you can write similar equations and find the value of that unknown quantity. So this is useful almost everywhere that you can think of. So let's go over these equations step by step and find out the process for solving for x. Now before we jump into the actual equations here, a few rules for manipulating these equations. So what is an equation? Equation says something like, so A is equal to B, or something on the left hand side is equal to something on the right hand side. This is called an equation because this is the equality sign, which is like this, and it signifies that the left hand side and right hand side are equal. And if you want to maintain the equality sign, and then there are certain operations that are allowed. If you perform the same operation on both sides of the equation, then the equality sign it continues, or it persists. So what are those operations? So let's write down some of the operations. So adding same number or subtracting same number, to both sides of the equation. There are more operations, but let's just first talk about these first two. So if I add the same number to both sides of the equation, or if I even add the same variable to both sides of the equation, so if I add a 10 to both sides of the equation, left hand side and right hand side, or if I subtract the same number or same variable, if I subtract x from both sides of the equation, then the equality sign does not change. Equality sign remains equality. Or multiply both sides by the same number or same variable, or divide both sides. We have to be a little careful here. Divide both sides by a non-zero number or variable. Then the equality sign persists, and we don't have to worry about whether the things on the two sides still are equal or not. So these are the basic operations, and we want to use these operations to solve equations. So let's take an example that will make things clearer. So what is the first one here? So it says 2x minus 5 is equal to 7. 2x minus 5 equal to 7. So I want to simplify left hand side and right hand side as much as possible. Usually the objective is we want to collect variables on one side and constants or numbers on another side, and we want to use these operations, these operations to perform the desired set of operations on the equation so that we get the value. So I see that there is a minus 5 here. So I want to add plus 5 to both sides so that this minus 5 goes away, and I want to isolate variables and constants. So let's see how that works here. So I have 2x minus 5 plus 5 is equal to 7 plus 5. I need to add the same constant to both sides. Now this minus 5 plus 5 is 0. So I get 2x is equal to 12. So now again I have 2x is equal to something. So I need to divide both sides by a number 2 to get variables on one side, that is x only on left hand side and everything else on the right hand side. So 2x divided by 2 is equal to 12 divided by 2. So this 2 cancels, and so therefore we get 6. So that's the solution. X is equal to 6 in this case. So if you go and see what we did here. So we first added 5 to both sides because I can add the same number to both sides. That cleared out the minus 5 on the left hand side. Then I got 2x is equal to 12, that's right here. And then I multiplied, or rather I divided both sides by 2 to get 12 divided by 2 equal to 6, and that's the value of x. Let's do this one more, a similar simple equation. So what do I have here? Second one is 5x plus 9 is equal to 24. So let's write that down. 5x plus 9 equal to 24. So we are going to follow a similar recipe here. We want to first subtract 9 from both sides because again my objective is to isolate variables and constants. So on left hand side I want only the variables, and right hand side I want only the constants. So let's reorganize this. I want to subtract 9 from both sides. So I have 5x plus 9 minus 9 is equal to 24 minus 9. So this plus 9 minus 9 is 0. So I get 5x is equal to 24 minus 9 is 15. So if I divide both sides by 3, or rather 5 in this case, is equal to 15 divided by 5. This is equal to 3. So I get x is equal to 3. So the same pattern as you can see from the previous example, that we add the same constant or subtract the same constant to both sides to simplify the equation, and then divide or multiply by the desired number to separate variables and constants, and finally we get x on the left hand side and a number on the right hand side, and that's your solution. So let's look at the third one. This is slightly more complex, so let's do this carefully. 2x plus 5 is equal to 4x minus 9. Let's see. 2x plus 5 is equal to 4x minus 9. Right, so here now as you can see there is x on both sides of the equation, and there is also constants on both sides of the equation. So as before we want to separate constants and variables. So let's start from the left hand side. Let's start with the constants on the left hand side. I see that the constant on the left hand side is 5, so I'm going to subtract 5 from both sides. So I have 2x plus 5 minus 5 is equal to 4x minus 9 minus 5. So this is 0, and I get 2x is equal to 4x minus 14. Right, so now I have x on both sides of the equation, and I want x to be only on the left hand side and not on both sides. Right, so let's subtract 4x from both sides. So that will get rid of the 4x on the right hand side. So I have 2x minus 4x is equal to 4x minus 14 minus 4x. So this plus 4x and minus 4x goes away, and 2x minus 4x being minus 2x is equal to minus 14. Now I can multiply both sides by minus 1. I'm allowed to do that just to make sure that the equation looks familiar to what we have here. So minus 2x times minus 1 is equal to minus 14 times minus 1. And the negative number of a negative number being positive, I get 2x is equal to 14. And now this is simple. We divide both sides by 2. 2x divided by 2 is equal to 14 divided by 2. which is 7. So finally I get x equal to 7. This is a slightly more involved example, but it can happen in practice that both sides of the equation have a variable or a constant, and then we follow the same rules. Basically, we need to add, subtract, multiply, divide by the same number, and we still maintain the equality sign. So that's what we want. Here is the fourth one is a slightly more complex, but it's only conceptually is the same. It's only numerically more complex. So let's see what it is. So 2x divided by 3 minus 8 is equal to x minus 7. So 2x by 3 minus 8 is equal to x minus 7. One thing to note, I think you already know this, but let's reiterate this, that the sequence of operations is so multiplication and division happen first and then addition and subtraction. So here, as you can see here, 2x by 3 minus 8, the operation of division here will be done first and then the subtraction. That's the convention that we follow. And between multiplication and division, we follow left to right. Same thing with addition and subtraction, just follow left to right. But if there is multiplication and addition both, then do the multiplications first, do all the multiplications first, and then do the addition. An even higher priority operator would be the bracket. So whatever is inside the bracket, solve that first and replace that by one number or one variable that you get. And so that's how the order of operations works. So here in this case, I have 2x divided by 3 minus 8 is equal to x minus 7. As before, let's start isolating the variables on one side and constants on the other. So 2x divided by 3 minus 8 plus 8 is equal to x minus 7 plus 8. I'm adding 8 to both sides. This is 0. So 2x divided by 3 is equal to x plus 1. Now I want to multiply both sides by 3 so that the fraction on the denominator goes away here. So I have, let me just make sure that I am doing this right. 2x divided by 3 minus 8 is equal to x minus 7. Was it x plus 7? It is x minus 7. Okay, that's good. Okay, so 2x divided by 3 minus 8 is equal to x minus 7. We added 8 to both sides. That's good. So now I'm going to multiply both sides by 3. So 2x divided by 3 times 3 is equal to 3 times x plus 1. So I get 2x is equal to 3x plus 3. So if I move this 3x to the left hand side, let's see what we get. So 2x minus 3x, that's another way of doing the equation. I'm just 3x plus 3 minus 3x. Subtracting 3x from both sides is another way of saying the same thing. What I just now said is, let's move this 3x on the left hand side. It's like when equation like this is given, you can move stuff on the left hand side or right hand side by flipping the sign. So this is 0. So therefore I get minus x is equal to 3. Or if I multiply both sides by minus 1, I get x is equal to minus 3. So that's how we get x is equal to minus 3. One way to verify what we did is correct or not correct is to also substitute back and see if the final number that we got makes sense. Let's substitute and check that our work is correct. So I want to substitute x equal to minus 3 in the given equation. Let's see if that our work is correct or not correct. So substitution. So 2x divided by 3 minus 8. So at x equal to 3, x equal to minus 3. So I have this 2x, so I have this 2 times minus 3 divided by 3 minus 8, which is, this is minus 1, minus 2, minus 8, which is minus 10. And the right hand side is x minus 7. I want this at x equal to, so I have x minus 7 is equal to minus 3 minus 7 is equal to minus 10. So our answer matches here. Minus 10 is the left hand side and minus 10 is also the right hand side. So we have indeed solved the equation, and our solution, that is this x equal to 3, x equal to minus 3, is correct. So that's how we solve basic linear equations in one variable. We can add, subtract, multiply, or divide by the same number as long as we are not dividing by 0. And that's how we can manipulate the two sides. We want to isolate variables on one side and the constants on the other side, and that's about it.